There, welcome to another round or session or trip to a random article through a random Wikipedia article into different kind of worlds. Um, and the best part is no one knows uh, what what places or what articles we're gonna travel through. So we don't know what random article we're gonna see. Obviously, that's why it's random, right? So we don't know which article we're gonna start from and where we're gonna end up. Um, and that's why I kind of like this, and I actually enjoy doing this because, like I said, it's a mystery. It's a mystery, and let I let the randomness of the AI in this system, in this instance, but randomness of the reality decide that we're gonna be learning about 1,000 piacia or piacia. How should I pronounce this? Piazza? I think it's piazza. Anyways, so provisional designing 1923 NZ or NZ is a carbonaceous background asteroid from the outer region of the asteroid belt. Okay. Approximately 48 kilometers in diameter. It was discovered on 12th August 1923 by German astronomer Karl Reinmuth at Heidelberg Observatory in southern Germany. The C type asteroid has a rotation period of 9.5 hours. It was named after Italian Giuseppe Piazzi, who discovered one Ceres. Okay, so this asteroid from the outer region of the asteroid belt, so that's pretty far. I'm assuming it's very very far from Earth. Yeah. Um, because asteroid belt sort of um, split the inner planets and outer planets, right? The inner planets are obviously Mercury, Venus, Earth, and Mars. And the outer planet would be then Saturn, Jupiter, Neptune, Uranus, and um, some sort of unknown planet. So the asteroid belt is a torus shaped region in the solar system, located roughly between the orbits of the planets Jupiter and Mars. Right? Okay. It contains a great many solid, irregular shaped bodies of many sizes, but much smaller than planets, called asteroids or minor planets. The C-type carbonaceous asteroids are the most common variety, forming around 75% of known asteroids. They are volatile rich and distinguished by a very low albedo because their composition includes a large amount of carbon, in addition to rocks and minerals. And the rotation period of a celestial the rotation period of a celestial object may refer to its sidereal rotation period, that is, the time that the object takes to complete a single revolution around its axis of rotation relative to the background stars, measured in sidereal time. So, Mr. Giuseppe Piazzi was an Italian Catholic priest of the Theatine order, mathematician, and astronomer. He established an observatory at Palermo, now the Osservatorio Astronomico di Palermo. Giuseppe S. Viana. Perhaps his most famous discovery was the first dwarf planet, I'm assuming, or dwarf asteroid. Who discovered one Ceres. Ceres is a dwarf planet in the asteroid belt between the orbits of Mars and Jupiter. Ceres was the first asteroid discovered on 1st January 1801 by Giuseppe Piazzi at Palermo Astronomical Observatory in Sicily. Originally considered a planet, it was reclassified as an asteroid. Whereas an asteroid is a minor planet of the inner solar system. Historically, these terms have been applied to any astronomical object orbiting the Sun that did not resolve into a disk in a telescope and was not observed to have characteristics of an active comet, such as a tail. An asteroid is a minor planet of the inner solar system. Historically, these terms have been applied to any astronomical object orbiting the Sun that did not resolve into a disk in a telescope and was not observed to have characteristic of an active comet, such as a tail. Piazzi is a non-family asteroid from the main belt's background population. It orbits the Sun in the outer asteroid belt at a distance of 2.4 to 4.0 AU, which should be astronomical unit. Yeah, okay. The astronomical unit is a unit of length, roughly the distance from Earth to the Sun. Right, okay. And equal to about 150 million kilometers or 8 light minutes. The actual distance from Earth to the Sun varies by about 3% as Earth orbits the Sun, from a maximum to a minimum point. Okay. So 2.4 to 4 AU, meaning roughly 8 times 2.4 to 8 times 4. 16. So that would be 19.2 to 32 minutes. It orbits the Sun in the outer asteroid belt at a distance. Okay, so it takes 19.2 minutes to 32 minutes for the light to come from sun to this asteroid. So like it takes 8 minutes for the light from the sun to come to the earth, um, because the distance between the earth and the sun is around 8 times the speed of the light. 8 times the velocity of the light. Yeah, because I think so. I think so, but I'm not sure. I guess we'll find out. Piasia is a non-family asteroid from the main belt's background population. It orbits the Sun in the outer asteroid belt at a distance of 2.4 to 4.0 AU once every 5 years and 8 months. Wow. 2063 days. Semi-major axis of 3.17 AU. Its orbit has an eccentricity of 0.26 and an inclination of 21 degrees with respect to the ecliptic. As no precoveries were taken, the body's observation arc begins with its first recorded observation on the night following its official discovery date. All right. $100,000th numbered minor planet. Wow. So 100,000 Astronautica, provisionally designed 1982 SH, is a sub-kilometer asteroid and member of the Hungaria family from the innermost region of the asteroid belt, approximately 940 meters, 0.58 miles in diameter. It was discovered on 28 September 1982 by American astronomer James someone. A minor planet is an astronomical object in direct orbit around the Sun that is neither a planet nor exclusively classified as a comet. Before 2006, the International Astronomical Union officially used the term minor planet, but during that year's meeting, it reclassified minor planets. I guess now we call them asteroid. Wow. Let's see. These are followed by the asteroids. Okay, so maybe these were like different asteroids discovered. What do I wanna learn, or what am I curious about? Okay, let's go to asteroid belt. The asteroid belt is a torus-shaped region in the solar system, located roughly between the orbits of the planets Jupiter and Mars. It contains a great many solid, irregularly shaped bodies of many sizes, but much smaller than planets, called asteroids or minor planets. This asteroid belt is also called the main asteroid belt or main belt to distinguish it from other asteroid populations in the solar system, such as near Earth asteroids and Trojan asteroids. A near Earth object is any smaller is a near Earth object is any small solar system body which orbit brings it into proximity with Earth. By convention, a solar system body is a NEO if that's closest approach to the sun is less than 1.3 astronomical units. In astronomy, a Trojan is a small celestial body, mostly asteroids, that shares the orbit of a larger one, remaining in a stable orbit approximately 60 degrees ahead of or behind the main body near one of its Lagrangian Lagrangian points L4 and L5. Trojans can share the orbits of planet or of large moons. The asteroid belt is the smallest and innermost known circumstellar disk in the solar system. About half its mass is contained in the four largest asteroids: Ceres, Vesta, Pallas, Hygiea. The total mass of the asteroid belt is about 4% that of the moon. That's so low, so less mass. Ceres, the only object in the asteroid belt large enough to be a dwarf planet, is about 950 kilometer in diameter, whereas Vesta, Pallas, and Hygiea have mean diameters less than 600 kilometers. The remaining bodies range down to the size of a dust particles. The asteroid material is so thinly distributed that numerous unmanned spacecraft have traversed it without incident. Nonetheless, collisions between large asteroids do occur, and these can produce an asteroid family whose members have similar orbital characteristics and compositions. Individual asteroids within the asteroid belt are categorized by their spectra, with most falling into three basic groups: carbonaceous C type, silicate S type, and metal rich M type. Ceres is a dwarf planet in the asteroid belt between the orbits of Mars and Jupiter. Ceres was the first asteroid discovered. Yeah, we already went through this. Vesta is one of the largest objects in the asteroid belt with a mean diameter of 525 kilometers. It was discovered by the German astronomer Heinrich Wilhelm Meth- Meth- Mathias Albers. Sorry, Heinrich, if I messed up your name. It is too long. And that's funny because I sort of know Indian names are super long. So, uh, all right. So it was discovered by German astronomer Heinrich on 29 March 1807 and is named after Vesta, the virgin goddess of home and heart from Roman. Pallas is the second asteroid to have been discovered after one Ceres. Like Ceres, it is believed to have a mineral composition similar to carbonaceous chondrite meteorites. though significantly less hydrated than Ceres. It is the third largest asteroid in the solar system by both volume and mass. Hygiea is a major asteroid and possible dwarf planet located in the main asteroid belt, with a diameter of 434 kilometers and a mass estimated to be 3% of the total mass of the belt. It is the fourth largest asteroid in the solar system by both volume and mass. A spectrum is a condition that is not limited to a specific set of values but can vary, without gaps, across a continuum. The word was first used scientifically in optics to describe the rainbow of colors in visible light after passing through a prism. As scientific understanding of light advanced, carbonaceous. Carbon is a chemical element with the symbol C and atomic number 6. It is non-metallic and tetravalent, making 4 electrons available to form covalent chemical bonds. It belongs to group 14 of the periodic table. Carbon makes up only about 0.025% of Earth's crust. In chemistry, a silicate is any member of a family of anions consisting of silicon and oxygen, usually with the general formula SiO. And okay, I I think that 4 minus x kind of determine number of oxygen, right? In this case, and 4 minus 2x on the top. That what does that define? I don't remember. My organic chemistry is uh, pretty weak right now. All right. So C type. C type carbonaceous asteroids are the most common variety, forming around 75% of known asteroids. They are volatile rich and distinguished by a very low albedo because their composition includes a large number of carbon in addition to rocks and minerals. And yes, I know we already checked that out somewhere in the last I think it's somewhere in the previous page on the previous page. S-type asteroids are asteroids with a spectral type that is indicative of a siliceous mineralogical composition, hence the name. They have relatively high density. Approximately 17% of asteroids are of this type, making it the second most common after the C type. And was an issue displaying the preview of M-type. The asteroid belt formed from the primordial solar nebula as a group of planetesimals. Planetesimals are the smaller precursors of the protoplanets. Between Mars and Jupiter, however, gravitational perturbations from Jupiter imbued the protoplanets with too much orbital energy for them to accrete into a planet. Collisions became too violent, and instead of fusing together, the planetesimals and most of the protoplanets shattered. As a result, 99.9% of the asteroid belt's original mass was lost in the first 100 million years of the solar system's history. Some fragments eventually found their way into the inner solar system, leading to a meteorite impacts with the inner planets. Asteroid orbits continue to be appreciably put to bed whenever their period of revolution about the Sun forms an orbital resonance with Jupiter. At these orbital distances, a Kirkwood gap occurs as they are swept into other orbits. I lost the point long up here. The asteroid belt formed from the primordial solar nebula as a group of planetesimals. The formation of the solar system began about 4.6 billion years ago with the gravitational collapse of a small part of a giant molecular cloud. Most of the collapsing mass collected in the center, forming the Sun, while the rest flattened into a protoplanetary disk out of which the planets, moon, asteroids, and other elements within solar system are formed. Planetesimals are solid objects thought to exist in protoplanetary disks and debris disks. Per the Chamberlain molten planetesimal hypothesis, they are believed to form out of cosmic dust grains, believed to have formed in the solar system about 4.6 billion years ago. A protoplanet is a large planetary embryo that originated within a protoplanetary disk and has undergone internal melting to produce a differentiated interior. Protoplanets are thought to form out of kilometer sized planetesimals that gravitationally perturb each other's orbit. Gravity or gravitation is a natural phenomena by which all things with mass or energy, including planets, stars, galaxies, and even light, are attracted to one another. On Earth, gravity gives weight to physical objects, and the moon's gravity causes the tides of the oceans. In astrophysics, accretion is the accumulation of particles into a massive object by gravitationally attracting more matter, typically gaseous matter, in an accretion disk. Most astronomical objects, such as galaxies, stars, and planets, are formed by accretion processes. Alright, so collisions became too violent, and instead of fusing together, the planetesimals and most of the protoplanets shattered. As a result, 99.9% of the asteroid belt's original mass was lost in the first 100 million years of the solar system's history. Some fragments eventually found their way into the inner solar system, leading to meteorite impacts with the inner planets. Asteroid orbits continue to be appreciably perturbed, perturbed, I think, appreciably perturbed whenever their period of revolution from the Sun forms an orbital resonance with Jupiter. At these orbital distances, a Kirkwood gap occurs as they are swept into other orbits. In astronomy, perturbation is the complex motion of a massive body subject to forces other than the gravitational attraction of a single other massive body. The other forces can include a third body, resistance as from an atmosphere, and the off center attraction of an oblate or otherwise misshapen body. Classes of small solar system bodies in other regions are the near Earth objects, the Centaurus, Centaurus, Centaurs, the Kuiper belt objects, the scattered disk objects, the Sednoids, and the Oort cloud objects. What are these? Okay. Small solar system body is an object in the solar system that is neither a planet, a dwarf planet, nor a natural satellite. The term was first defined in 2006 by the International Astronomical Union as follows: all other objects except satellites orbiting the sun. Okay. We already sort of went through the near Earth object. I think I'm gonna select that as my next article. In planetary astronomy, a centaur is a small solar system body with either a perihelion or a semi-major axis between those of the outer planets. Centaurs generally have unstable orbits because they cross or have crossed the orbits of one or more of the giant planets. The Kuiper belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units to approximately 50 AUs from the Sun. It is similar to the asteroid belt but is far larger, 20 times as wide and 20 to 200 times as massive. The scattered disk or scattered disk is a distant circumstellar disk in the solar system that is sparsely populated by icy small solar system bodies, which are a subset of the broader family of trans-Neptunian objects. The scattered disk objects, SDOs, have orbital eccentricities range of something. A sednoid is a trans-Neptunian object with a perihelion well beyond the Kuiper cleft at 47.8 AU. Only three objects are known from this population: 90377 Sedna, 2012 VP 113, and 541132 Leleaku Honua, 2015 TGO or whatever. But it is subjected that there are many more. All three have perihelia greater than 64 AU. So a sednoid is a trans-Neptunian object with a perihelion well beyond the Kuiper cliff. Only three objects are known from this population. So they are like moons of Neptune, I'm assuming. Sort of. The Oort cloud, sometimes called the opaque Oort cloud, first described in 1950 by the Dutch astronomer Jan Oort, is a theoretical concept of a cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 2000 to 200,000 AU. I still didn't get it. The Oort cloud, sometimes called the Opic Oort clouds, first described in 1950 by the Dutch astronomer Jan Oort, is a theoretical concept of a cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 2000 to 200,000 AU. Okay. So, but that sort of is past all the planets. The Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yeah. So yeah, it is like way past the solar. I shouldn't say solar system because I think it's still part of solar system, but um, way outside the planetary system, I guess. Wow. So our solar system have a ring of Oort cloud, I think. But he did say it's a theoretical, so we don't know yet. Okay. On 22nd January in 2014, European Space Agency scientists reported the detection for the first definitive time of water vapor on Ceres, the largest object in the asteroid belt. The detection was made by using the far infrared abilities of the Herschel Space Observatory. The finding was unexpected because comets, not asteroids, are typically considered to sprout jets and plumes. According to one of the scientists, the lines are becoming more and more blurred among comets and asteroids. Between comets and asteroid. I don't know if I said comets or comments when I said it for the first time. All right, so history of how they learned about the asteroid belt. But we wanna do you wanna go through the formation of asteroid belts? And then there is evolution of asteroid belts. Composition, which yeah, we went through C type, which are carbonaceous. S type, it's silicon and oxygen silicate, right? And M type, the information wasn't available. I think we gonna we gonna explore we're gonna explore we're gonna explore the Neos. Where are you, Neo? Neo. A near Earth object is any small solar system body whose orbit brings it into proximity with Earth. By convention, a solar system body is a NEO if its closest approach to the Sun is less than 1.3 astronomical units. If a NEO's orbit crosses the Earth's and the object is larger than 140 meters across, it is considered a potentially hazardous object. Most known PHOs and NEOs are asteroid, but a small fraction are comet. The PHO is potentially hazardous object. There are over 20,000 known near Earth asteroids and over 100 known short period near Earth comets. A number of solar orbiting meteoroids were large enough to be tracked in space before striking the Earth. It is now widely accepted that collisions in the past have had a significant role in shaping the geological and biological history of the Earth. Asteroids are as small as 20 meters in diameter can cause significant damage to the local environment and human populations. Larger asteroids penetrate the atmosphere to the surface of the Earth, producing craters if they impact a continent or tsunamis if they impact the sea. Interest in NEOs has increased since the 1980s because of greater awareness of this potential danger. Asteroid impact avoidance by deflection is possible in principle, and methods of mitigation are being researched. Okay. I was having some technical difficulties. Technically difficulties? Yeah. The term space guard loosely refers to a number of efforts to discover, catalog, and study near Earth objects, especially those that may impact Earth. What should we explore? There are a lot of risk scales. The simple Torino scale, which rates the risk of impacts in the next 100 years according to impact energy and impact probability using integer numbers between 0 and 10. And the more complex Palermo Technical Impact Hazard Scale, which ascribes ratings that can be any positive or negative real number. These ratings depend on the background impact frequency, impact probability, and time until possible impact. On both scales, risk of any concerns are indicated by values above zero. Claims of the existence of other moons of Earth, that is, of one or more natural satellites with relatively stable orbits of Earth other than the Moon, have existed for some time. Several candidates have been proposed, but none has been confirmed. Okay, what in the world is this? claims of the existence of other moons of Earth, that is, of one or more natural satellites with relatively stable orbits of Earth other than the moon, have existed for some time. Several candidates have been proposed, but none has been confirmed. Since the 19th century, scientists have made genuine research for more moons, but the possibility has also been the subject of a number of dubious non scientific speculations as well as a number of likely hoaxes. Although the moon is Earth's only natural satellite, there are a number of near Earth objects with orbits that are in resonance with Earth. These have been called second moons of Earth. 469219 Kamo'olawa, provisionally designated 2016 HO3, is a very small asteroid, fast rotator, and near Earth object of the Apollo group, approximately 40 to 100 meters in diameter. At present, it is a quasi satellite of Earth. So, 469219 Kamo Oalewa, an asteroid discovered on 27th April 2016, is possibly the most stable quasi satellite of Earth. As it orbits the Sun, oops, I shake the camera. I was trying to make myself comfortable, but my legs are killing me. Oh, no wonder we humans are not designed, again, designed not by a god or anything, designed by evolution to be just sitting. I mean, I sat for how long? It's just been 47 minutes. And, well, I was sitting at least 20 minutes before I started today's session, so it's been an hour since I haven't moved around, and my legs. And what scares me is to admit that it could get worse by age, by time. And that's one thing which is very difficult to digest because at this moment I feel like uh, I feel I have a lot of energy. I mean, it's 3 a.m. and I'm still awake. So, and I can push through a lot of things. I can still push myself through a lot of stress, and I've been doing that for a while too. And when I say stress, I don't mean like the negative stress only. There are a lot of positive stresses, like mental exercise, physical exercise, and any challenging things. So, regardless, like when uh, I can feel that my body can handle that stress, and the idea of a the of a time when I won't be able to handle that is kind of scary. It's very scary. I would rather hope that I die before I become a burden in a way. Well, the burden might be the wrong choice of word, but I would personally, first of all, I want my physical and mental fitness to be the best of my ability, and I'm not there yet, clearly. So that's one of the goals, and the goal is to age gracefully, to to live life um, to actually live life, to be alive and live life rather than just breathing and just going with the flow of whatever the world you know throw it on our way, I guess. But we're gonna do that regardless. But while being aware and aware of the process, or aware of uh, aware of the progress, aware of the exercise, or aware of the I mean awareness in general, right? But the larger point is that just by being aware, you could actually feel more alive. And when you feel more alive, then you're actually living a life and not just breathing. So it always come down to what make you feel aware. And different people have different things. Some are energized and become aware because of inspirational or motivational videos. Some become self-aware because of music. Some become self-aware because of maybe reading something or listening to some podcast, or some uh, conversation, or some preaching preachers, or whatever, right? So different people get energized in different way. But regardless, when one is energized, they are aware of the situation, aware of the moment, and that makes life worth living. So I do want to live through the life, um, and also age gracefully. And then when the time comes, or I should rather rephrase it as, I want my body to be to not fail until my death. You know what I mean? Like, I want everything within my body to function um, as it's programmed in a way, to just taking care of the inner organs, and nourishing the body with the right nutrients, and um vitamins and whatnot. So, uh, and I'm not there yet, obviously, like I said before. So hopefully, soon, soon we'll be there. Other small natural objects in the orbit around the sun may enter orbit around Earth for a short amount of time, becoming temporary natural satellites. Petit's moon. The first major claim of another moon of Earth was made by French astronomer Frédéric Petit, director of the Toulouse Observatory, who in 1846 announced that he had discovered a second moon in an elliptical orbit around Earth. It was claimed to have also been reported by Lebon and Dacier at Tollhouse, and by Lariviere at Artenac Observatory during the early evening of March 21st, 1846. Petit proposed that this second moon had an elliptical orbit, a period of 2 hours 44 minutes, with 3,570 kilometer apogee and 11.4 kilometer perigee. This claim was soon dismissed by his peers. The 11.4 kilometer perigee is similar to the cruising altitude of most modern airliners and within Earth's atmosphere. Petit published another paper on his 1846 observations in 1861, basing the second moon's existence on perturbations in movements of the actual moon. This second moon hypothesis was not confirmed either. Petit's proposed moon became a plot point in Jules Verne's 1870 science fiction novel Around the Moon. Apogee. An apsis is the farthest or nearest point in the orbit of a planetary body about its primary body. The apsides of Earth's orbit of the Sun are two: the aphelion, where Earth is farthest from the Sun, and the perihelion, which where it is nearest. Apsides can also refer to the distance of the extreme range of an object. Okay? So there are two apsides, aphelion and perihelion. And aphelion is when Earth is farthest from the Sun, and perihelion when Earth is nearest to the Sun. So there was another claim from George Waltimat, and that was for this Waltimat's moons. In 1898, Hamburg scientist Dr. Georg Waltermatt announced that he had located a system of tiny moons orbiting Earth. He had begun his search for secondary moons based on the hypothesis that something was gravitationally affecting the moon's orbit. Waltermatt described one of the proposed moons as being 1,030,000 kilometers from Earth with a diameter of 700 kilometers, a 119-day orbital period, and a 177-day synodic period. He also said it did not reflect enough sunlight to be observed without a telescope unless viewed at certain times, and made several predictions of its next appearances. Sometimes it shines at night like the sun, but only for an hour or so. I don't know if that's how he sounded. Definitely not. He was a German scientist. Or no, Hamburg scientist. Well, Hamburg, officially the Free and Hanseatic Hamburg, officially the Free and Hanseatic city of Hamburg, is the second largest city in Germany, after Berlin, as well as the overall seventh largest city and largest non-capital city in the European Union, with a population of over 1.84 million. Oh, look, we have Sprinkles in the house. Sprinkles, do you want to say something? How was your day? Hmm? How was your day? Did you chill? What did you do? Okay. Okay. Oh, is it? All right. Okay, okay. Don't be mad at me. I mean, it's your fault. All right. So, Easton Wiggins, a Canadian weather expert, ascribed the cold spring of 1907 to the effect of a second moon, which he said he had first seen in 1882. and had publicized the find in 1884 in the New York Tribune when he put it forward as probable cause of an anomalous solar eclipse of May of that year. He said it was also probable the green crescent moon seen in New Zealand and later in North America in 1886 for periods of less than a half hour each time. He said this was the second moon seen by Walter Math in 1898. Wiggins hypothesized that the second moon had a high carbon atmosphere but could be seen occasionally by its reflected light. The existence of these objects put forward by Waltemath and Wiggins was discredited after the absence of corroborating observation by other members of the scientific community. Especially problematic was a failed prediction that they would be seen in February 1898. The August 1898 issue of Science mentioned that Walter Math had sent the journal an announcement of a third moon, which he termed a War after Wetter und Magnet Mond, real weather and magnet moon. It was supposedly 746 kilometers in diameter and closer than the second moon that he had been seen previously. Okay, Sprinkles. Come on. Good. Do you want to say something to the world again? Okay. Okay, so moon is the moon, and then 1933 Great Meteor Procession 3753 Krutny 1991 VG 85770 1998 UP1. Oh, there are quite a few moons or Earth Trojan. Cool. Let's actually wrap this session with moon. Moon is the best way to end today's journey, I guess. Yeah, we gonna land on the moon. Nice. The moon is Earth's only natural satellite at about one quarter the diameter of Earth, comparable to the width of Australia. It is the largest natural satellite in solar system relative to the size of the major planet. The fifth largest satellite in the solar system overall and larger than any known dwarf planet. The moon is a planetary mass object that formed a differentiated rocky body, making it a satellite planet under the geophysical definition of the term. It lacks any significant atmosphere, hydrosphere, or magnetic field. Its surface gravity is about one sixth of Earth's. Jupiter's moon Io is the only satellite in the solar system known to have a higher surface gravity and density. The solar system's planets and its most likely dwarf planets are known to be orbited by at least 219 natural satellites or moons. At least 19 of them are large enough to be gravitationally rounded. Of these, all are covered by a crust of ice except for Earth's moon and Jupiter's Io. The atmosphere of the moon is a very scant presence of gases surrounding the moon. For most practical purposes, the moon is considered to be surrounded by vacuum. The elevated presence of atomic and molecular particles in its vicinity compared to interplanetary medium. The The hydrosphere is the combined mass of water found on, under, and above the surface of a planet, minor planet, or natural satellite. Although Earth's hydrosphere has been around for about 4 billion years, it continues to change in shape. This is caused by seafloor spreading and continental drift. The magnetic field of the moon is very weak in comparison to that of the Earth. The major difference is the moon does not have a dipolar magnetic field currently, so that the magnetization present is varied and its origin is almost entirely crustal crystal in location, so it's difficult to compare as a percentage. So, orbiting Earth at an average distance of 384,400 kilometers, or about 30 times Earth's diameter, its gravitational influence slightly lengthens Earth's day and is the main driver of Earth's tides. The moon's orbit around Earth has a sidereal period of 27.3 days. During each synodic period of 29.5 days, the amount of visible surface illuminated by the sun varies from none up to 100%, resulting in lunar phases that form the basis for the months of a lunar calendar. The moon is tidally locked to Earth, which means that the length of a full rotation of the moon on its own axis causes its same side, the near side, to always face Earth, and the somewhat longer lunar day is the same as the synodic period. That said, 59% of the total lunar surface can be seen from Earth through shifts in perspective due to libration. In lunar astronomy, libration is the wagging or wavering of the moon perceived by Earth-bound observers and caused by changes in their perspective. It permits an observer to see slightly different hemispheres of the surface at different times. It is similar in both cause and effect to the changes. The orbital period is the time a given astronomical object takes to complete one orbit around another object, and applies in astronomy usually to planets or asteroids orbiting the Sun, moons, orbiting planets, exoplanets, orbiting other stars, or binary stars. Name and etymology. This is what I was looking for, sort of. The usual English proper name for Earth's natural satellite is simply the Moon with a capital M. The noun moon is derived from Old English mona, which, like all its Germanic cognates, stems from Proto Germanic menon, which in turn comes from Proto Indo European mensis, month, from earlier menot, genitive menesis, which may be related to the verb measure of time. Occasionally, the name Luna is used in scientific writing, and especially in science fiction to distinguish the Earth's moon from others, while in poetry, Luna has been used to denote personification of the moon. Cynthia is another poetic name through rare, though rare, for the moon personified as a goddess, with Selene, literally moon, in the Greek is the Greek goddess of the moon. The usual English adjective pertaining to the moon is lunar, derived from the Latin word for the moon, luna. The adjective Selenian, derived from the Greek word for the moon, Selene, and used to describe the moon as a world rather than as an object in the sky, is rare. While its cognate selenic was originally a rare synonym, but now nearly always refers to the chemical element selenium. The Greek word for the moon does, however, provide us with the prefix seleno as a selenography, the study of the physical features of the moon as well as the element named selenium. The Greek goddess of the wilderness and hunt, Artemis, equated with the Roman Diana, one of whose symbols was the moon and who was often regarded as the goddess of the moon, was also called Cynthia from her legendary birthplace on Mount Cynthus. These names, Luna, Cynthia, and Selene, are reflected in technical terms for lunar orbits such as Apollon, pericynthian, and selenocentric. The astronomical symbol for the moon is crescent. Moon with a crescent is lunar mass. That's so weird. I mean, whoever wrote this just wrote it from like uh, one point of view. I guess like there are so many different. Well, how does different civilizations come to their naming convention? But I guess I get it because moon. Um, I mean, because globally we all call it moon, even though like different people call it with different names in their own language, and probably have their own stories of why they call moon with whatever word they use. And since globally we call it moon, it makes sense to kind of talk about just the name moon. But I'm hoping that there is some sort of philosophical section here, meaning like how other cultures, like every other culture, had different, call it relationship or call it different um, tradition with moon or to moon. I want to see what each of these phases are called. So new moon to first quarter, and then full moon, then last quarter, and then new moon. Okay. So new moon to first quarter is waxing crescent. And first quarter to full moon is waxing gibbous. Okay. From full moon to last quarter, waning gibbous. And from last quarter to new moon, waning crescent. Now I'm kind of curious what is waxing, what is waning, and what is gibbous. If I have to guess, let's see. If I have to guess, gibbous would be. Wait. Wait. Is it, does Wikipedia have? Wow. Is that Wikipedia or Mac? I can't tell. I think it's Wikipedia. All right. So waxing crescent, the monthly changes in the angle between the direction of sunlight and view from Earth and the phases of the moon that result as viewed from the northern hemisphere. The Earth moon distance is not to scale. So it's a kind of like a warning method for the entire photo. Hmm. Yeah, I thought like they have like some sort of like underline there, and for each of those waxing crescent, I'm sure they must have mentioned it somewhere. What is this? Sizik. In astronomy, a syzygy is a roughly straight line configuration of three or more celestial bodies in a gravitational system. Oh, that's such a cool name. Syzygy. I want to kind of check that out. Maybe later. Solar corona during full moon. Sorry, during solar eclipse. Galileo's sketches of the moon from the groundbreaking Sidereus Nuncius. In 1609, Galileo Galilei used an early telescope to make drawings of the moon for his book Sidereus Nuncius, and deduced that it was not smooth but had mountains and craters. Thomas Harriot had made but not published such drawings a few months earlier. Telescopic mapping of the moon followed. Later in the 17th century, the efforts of Giovanni Battista Riccioli and Francisco Maria Grimaldi led to the system of naming of lunar features in use today. The more exact 1834 to 1836 Mappa Selenographica of Wilhelm Beer and Johann Heinrich Matler, and their associated 1937 book Der Mond, the first trigonometrically accurate study of lunar features, included the heights of more than 1,000 mountains, and introduced the study of the moon at accuracies possible in earthly geography. Lunar craters first noted by Galileo were thought to be volcanic until the 1870s proposal of Richard Proctor that they were formed by collisions. This view gained support in 1892 from the experimentation of geologist Grove Carl Gilbert and from comparative studies from 1920 to 1940s, leading to the development of lunar stratigraphy, which by the 1950s was becoming a new and growing branch of astrogeology. Mm-hmm. different missions by different countries. And there are future missions lined up. Yeah, that's the other plan thing, right? Like another man or human um, landing on moon. The moon will be include a female astronaut. Wait, on 28th February 2018, SpaceX, Vodafone, Nokia, and Audi announced a collaboration to install a 4G wireless communication network on the moon with the aim of streaming live footage on the surface to Earth. That would be awesome. That would be awesome. India had also expressed its hope to send people to the moon by 2020. What? Oh, that was back in 2008 or 2006. Good luck, India. I know you can, but I was actually watching this YouTube video and how India over the past few decades have revolutionized the space industry or space agency. The ISRO, the Indian Space Research Organization, which you know, which is sort of equivalent to NASA here, right? And ISRO designed so many different satellites and so many different um, uh, well, there were satellites from a lot of companies, but I think there were the ISRO even designed like a lot of satellites which could, which was launched towards Mars. I'm blanking on the name of the satellite, but even the Chandrayaan satellite, which was launched to orbit Moon, I believe, and that satellite was no, the satellite which India launched to towards Mars to orbit Mars. That's the entire project cost was less than the budget of movie Mars. So basically, India India innovatively used the resources, and I'm sure they cut down on so many different um, um, advancement of the technology, I guess, because if you can carry only limited weight with a limited purpose, then you have with a limited budget, then you have to limit down the purpose of the mission. So they did trim down the um, I guess the original mission goals maybe, but they did accomplish such a huge um, they did. Why am I saying they? I mean, we did accomplish such a huge feat by launching a satellite in the orbit of Mars. But let's see. NASA began to plan to resume human missions following the call by U.S. President George W. Bush on 14 January 2004 for a human mission to the moon by 2019 and the construction of a lunar base by 2024. The Constellation program was funded and construction was and testing began on a crewed spacecraft and launch vehicle and design studies for a lunar base. That program was cancelled in 2010. However, and was eventually replaced with the Donald Trump supported Artemis program, which plans to return humans to the moon by 2025. India had also expressed its hope to. That's strange. So George W. Bush resumed the human mission to the moon, and 2010 it was cancelled in 2010. So clearly Obama cancelled that, and Donald Trump supported the Artemis program. So that's the opposite of what I would expect from the craziness we have in the politics. So there could be that there is some sort of nefarious reason to start this mission or to resume this mission. Sure, maybe just to funnel money to the military industrial complex who could design technology for space and then embedded with, like, I don't know, some sort of guns and security. So when I say security, I mean, like, explosives or something. Who knows? The Artemis program is a United States-led international human space flight program. Its primary goal is to return humans to the moon, specifically the lunar South Pole, by 2025. If successful, it will include the first crewed lunar landing mission since Apollo 17 in 1972. Yeah, that's like one of the good things. um, I'm hoping that this program is not canceled by Joe Biden, because look like Obama did. Planned commercial missions. Okay, in 2007, the X Prize Foundation, together with Google, launched the Google Lunar X Prize to encourage commercial endeavors to the moon. A prize of 20 million was to be awarded to the first private venture to get to the moon with a robotic lander by the end of March 2018, with additional prizes worth 10 million for further milestones. As of August 2016, 16 teams were reportedly participating in the competition. In January 2018, the foundation announced that the prize would go unclaimed, as none of the finalist team would be able to make a launch attempt by the deadline. In August 2016, the US government granted permission to US-based startup Moon Express to land on the moon. This marked the first time that a private enterprise was given the right to do so. The decision is regarded as a precedent, helping to define regulatory standards for deep space commercial activity in the future. Previously, private companies were restricted to operating on or around Earth. Well, we love money, don't we? So we will sell it. We will sell every ounce of reality to 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 the businesses to be able to exploit it. I mean, I think there are a lot of things which shouldn't be sold to the companies. I mean, obviously natural resources, which include everything, right? Like oil, coal, metals, and any other resources. These are the natural resource of the land. So those resources belong to the people. Um, there is a different conversation if someone purchased a property from someone else and then discovered that there were, I don't know, maybe like a some sort of hidden natural resource there, and then it's a different conversation. But I still think if that's the case, then well, um, then that person should be handsomely compensated, maybe even with the percentage, for example, right? Like if imagine if you bought a property, a land, and the land is huge, like you say, hundreds of acres, and like somewhere in there was an opening, rather opening underground into a gold mine. Right now, you own a land which have gold mines buried underneath. So clearly, if you sell it to anyone, why would you sell it to anyone, first of all, right? And you would definitely don't, you won't want government to kind of seize that land from you. So what I think would be happy medium would be like government just to give the percentage, and since the land belongs to the people, or the resources belong to the people, so the government can just give a percentage to that person, like for every, say, for every gram of gold mined from that mine, that person will get X percentage, could be even 0.001% of that gram, sort of like a reward or a compensation or dividend or whatever. And this way, it's a win-win situation, because the person who originally owned the land would be able to, just have, first of all, they can happily give it away to the government, I'm hoping, because because that's a consistent income which they can generate. Doesn't matter if someone mines 100 kgs of gold, they're going to get their percentage. And the best part for government would be, they can they can use the resources, in a better way to improve the lives of the people. And of course, I know in reality, none of these things will happen. The government might or could forcefully seize the resources and, give the mining leash to one of their donors or cronies who gonna mine the shit out of those mines, and they're gonna eat away almost all the profit, uh, and the people will suffer. So things like that is pretty common, and even how bad it may sound, that is what reality is. But I think I'm gonna wrap up today's session. It's been almost hour and a half. That was a long session, and I kind of enjoyed it. I loved it. I feel that this is doing this is helping me personally. So I'm doing this for selfish reasons now. And just by going through various articles, I feel that uh, I feel the beauty of how randomness can teach and can quench the thirst of curiosity, and shows the connection of various concepts and various thoughts, and how everything in the world is connected, and you can try and find that common connection to different things, and you don't have to do it um, unless you want to do it, right? So at the end of the day, if you want to form a connection, say with something, right? Like, let's just say with this camera, I'm streaming from. So there are a lot of things common between the camera and me, which because camera is essentially the eye of the equipment, right? So uh, and I have an eye, and the principle is same to both captures the light, and the light sort of reflecting from my um, body is being captured in that camera. So that's how the camera can basically paint a picture, or the camera can create that image where it's capturing the reflections from my body, and that is uh, that is exactly how we use our eyes too, right? That's one of the reasons we can't see in the dark, um, because there is no light. When I say light, I mean visible spectrum. Because of course there is, like, UV radiations or infrared, but our eyesight is very limited, and so is cameras, right? So a camera cannot function in UV or ultra red, because it's not equipped with that. The input, the hardware is not equipped to be able to see in different frequencies like our eyes. So there you go. That's the connection. So um, yeah, I love how Wikipedia articles connect and create this beautiful montage. And we're gonna be back again with this beautiful montage, and we're gonna go on another journey and go with the